Welcome to SS2 Technical Drawing. This time we begin with Descriptive Geometry, the branch of geometry that deals with representing three-dimensional objects on a two-dimensional drawing surface. Descriptive geometry is the mathematical foundation of all engineering, architectural, and technical drawing. It was formally developed by Gaspard Monge, a French mathematician, in the 18th century, and it remains the backbone of how engineers and designers communicate spatial information today. In this lesson, we focus on the most fundamental elements, points and lines. A point has no size, it is a location in space. On a drawing, we represent a point as a small dot or cross. A line is defined by 2 points. In descriptive geometry, we work with two principal planes of projection, the horizontal plane, called the HP, and the vertical plane, called the VP. Where they intersect, we have the reference line, called the XY line. When we project a point onto these planes, we get two views, the front view, which appears above the XY line, and the plan view, which appears below it. Every technical drawing student must master this system because it forms the basis for understanding how three-dimensional objects are drawn in 2 dimensions. In Nigeria, the WAEC Technical Drawing Examination tests students extensively on descriptive geometry, so a strong foundation here will serve you throughout your studies. Let us now understand how to project a point in space onto our 2 principal planes. Imagine a point P floating in space above the HP and in front of the VP. To find its projection on the HP, we drop a vertical projector from P straight down to the HP. The spot where it lands is called P, lowercase, and it is the plan view of P. To find its projection on the VP, we draw a horizontal projector from P straight back to the VP. The spot where it lands is called P', and it is the elevation or front view of P. Now when we open out the HP by rotating it downward to lie flat in the plane of the VP, our drawing sheet, the plan view P falls below the XY line and the elevation P' appears above the XY line. This unfolding is fundamental. Always remember, elevations go above the XY line, plan views go below. The vertical distance from the XY line to P' tells us how high the point is above the HP. The vertical distance from the XY line to P tells us how far the point is in front of the VP. These 2 measurements completely define the position of the point in space. Practice projecting individual points before moving to lines, because lines are simply 2 projected points connected together. A line in descriptive geometry is defined by its 2 endpoints. To draw a line AB in both views, we project point A and point B individually onto both the HP and the VP, then connect the corresponding projections. On the elevation view, we connect A' to B' to get the front view of the line. On the plan view, we connect A to B to get the plan view of the line. Lines can be in various positions relative to the principal planes. A line that is parallel to both the HP and the VP is called a line parallel to the XY. It appears as a point in both views, but that is a special case. A line that is parallel to the HP but inclined to the VP appears in true length in the plan view. A line that is parallel to the VP but inclined to the HP appears in true length in the elevation view. A line that is inclined to both planes appears foreshortened in both views, and we must use auxiliary projections to find its true length. In your WAEC examination, you will often be given 2 views of a line and asked to find its true length or the angle it makes with a plane. Understanding the relationship between the views is the key to solving such problems. Always draw neatly with a sharp pencil and label all points clearly. Accuracy in descriptive geometry is critical. Let us recap the key points from today. Descriptive geometry uses 2 principal planes, the HP and the VP, intersecting along the XY line. Points are projected onto both planes. The plan view falls below XY, the elevation above. A line is defined by projecting its 2 endpoints. Lines parallel to one plane appear in true length on that plane. Lines inclined to both appear foreshortened in both views. For WAEC success, always label your points neatly using capital letters for space points and lowercase for their projections. Draw your XY line clearly and mark distances accurately. Practice unfolding problems at home by imagining a cardboard box open flat. Next week we move to finding the true length of lines, which builds directly on what we learned today. Review your notes and attempt practice problems from past WAEC papers before next class. Well done for completing week 1 of term 1.